Alright, so here there are a few questions written down for C1 for exam practice. There are 4 questions here, 1, 2, 3, 4 questions. I'm going to explain to you how to do these questions. Right, you can stop this video anytime and you can just do these things yourself at this point, and you can check with me or whatever you want. Yeah, so I'm just going to explain that from the first question. So let's do it from the first one. Right. The question 1 basically says expand that expression. Expand root 7 minus 7 times by root 8 plus 8. Okay, so let's do this. Root 7 times root 8, you can have root 56. Right, root 7 times root 8, root 56. Because they both are roots, so the root remain. I mean, it's the third sign, the root sign remain. Root 7 times 8, just normal 8 would be 8 root 7. Because it's like saying there are 8 of root 7s, like timesing, normal. The other one, minus 7 times root 8, would be minus 7 root 8. The same idea. The other one, minus 7 times 8, would be minus 56. Now maybe we can simplify this one a bit. Let's say the question was expand and simplify for the maximum. Okay, so let's say we try to simplify a bit. We can break this one down. 8 root 7 cannot be simplified further, that's it. But we can simplify this guy, saying 8 can be written 4 times 2. Okay, and 56 can be written as 4 times 14. 4 times 14. Alright, so root 4 basically equals to 2, so you're going to get 2 root 14 plus 8 root 7. Now changes there. Here root 4 is again 2. 2 times 7 is 14, minus 14 root 2 minus 56. So that's the most simplified version of the answer. If they ask you to expand and simplify, you have to simplify to the max as much as possible. Otherwise, even though your answer is right, otherwise you might lose some marks. Right, cool. That's the part A. Part B, question 1 still. Hence or otherwise, show that this fraction, there are 2 surds on top of each other, written as this, a plus b root 2. Right, so so how are we going to do that? I mean, if you look at this carefully, the answer we got here, okay, the answer we got here and this denominator are exactly the same, isn't it? 2 root 14, 8 root 7, minus 14 root 2, minus 56. So we try to simplify this one basically. They're saying they want us to simplify this. Into a format of a plus b root 2. Right? Now this is actually difficult. It's appear to be just like, difficult to get into any sort of, they basically want us to rationalize it, isn't it? Rationalize it. This question is asking to rationalize this. So doing like that is pretty difficult. But we can actually get some aid from the previous part, like they're saying, hence or otherwise. So we can probably use the previous answer. We know this is basically equal to that. Because why? We have simplified that and we have gotten that. So I can replace this with that and see what you're going to get. I hope you follow the logic here. I'm going to replace this with that because they're exact same. You can stop this video anytime and you can follow your own intuition and try it yourself. So don't spoil it, Cool. Right, so that's something look much better now. And we can see still it's not nowhere near that. We can look at this here. Root 2 is on the top, is a common factor because root 14 can be written as root 2 times root 7 minus 7 root 2 divided by root 7 minus 7 8 plus root 8. Okay. The reason I could see that can be written like root 7 minus root 7. When I take that root 2 out, then I can cancel things out. That's the reason. So common factor is root 2 there. So root 7 minus 7 divided by root 7 minus 7 times 8 plus root 8. Now they're cancelling out. Okay, so what we're going to get here, root 2 on the top, the bottom 8 plus root 8. Now they are still not compatible with the format. Now we can rationalize the denominator. Rationalize this. The denominator. How do you rationalize the denominator? Basically, we can times this one by 8 minus root 8. The top also by 8 minus root 8. I hope you can remember rationalizing the denominator. Okay. So what we're going to get here, if we expand it, I hope now we can expand these things. I'll do quickly. If you expand it, you're going to get basically 64 minus 8. On the top, you're going to get 8 root 2, because 8 times root 2, 8 root 2, root 2 times root 8 minus root 16. Okay, so that yields, that is 4 basically. 8 root 2 minus 4 divided by, that is 56 again, isn't it? 56. 56. I'll probably simplify a bit more. Common factor here, common factor is 4. Take it out. 56. 4 times 1, 4 times 14. Okay, so the answer we're going to get basically, I'm going to write it. Okay, let me write here. The answer we're going to get root 2 over 14 or 1 over 14 minus 1 over 14. That's it. That's the answer. That's certainly in the format of that. So A equals to minus 1 over 14 over 14th. B equals to 1 over 14 as well. So A and B are exactly equal in a sense. They have different signs. Okay, so that's basically it. So let me write the answer here if you want a different color to make it big visible. You write the answer here. Minus root 14 plus root 14 times that. You can write it like this if you want. Okay. So cool. So that's the question 1. All right. So let me go to question number 2 basically. I'm going to delete this basically to get some space again. It's going to mix up with the others. Right, okay, so let's look at the question number 2. Question number 2 says actually it's probably is a much more simpler question. Question number 2 says simplify, evaluate that. Evaluate that expression. Now let me write the expression here again. 27 over 64 minus x minus 3 over 2 on the top again minus 2/3. Right. So what we should do here basically, which you can think, like I said, you can stop this video anytime and you can think yourself. There are a few operations here. There are a few operations. I would say there are 3 operations. One is the cube root of it. Take the cube root and you have to square it, and after you have to take the negative power. So there are 3 steps. First, cube root. Cube root the whole thing, because why there's a cube root there. And the second number 2 will be square it. Last one, negative power, raised to the negative 1. Isn't it? Really? Or negative index for the whole thing. So let's do these steps one by one and we should get the answer then. Let's find the cube root of this. So what I'm going to do, I'm going to perform the first operation. So I'm not really bothered about other 2, the squaring or minus 1. So I'm writing it like this, like a third. Okay? So that's going to yield 27, cube root of 27. I can just times those things like that. And the cube root of minus 2/3. So when you do the second one, however, we can times these things together. 1 times 3 is minus 3. 2 times 3 is 6. So you're going to have minus 3 over 6. The other one is 64, again a cubic root. It's pretty, I think, straightforward. The reason we can write third like that, because why? We have a power here, even though it's invisible. So third times 1. Exact same thing we employed here as well. Minus 3 over 2 times a third. So 1 times minus 3 is minus 3. 2 times 3 is 6. Exact same thing. Okay? So the cube root of 27 would be 3. That's basically simplified to minus a half. Cube root of 64. That is 4. Basically. Because we know 4 times 4 times 4 is 64. In here, 3 times 3 times 3 is 27. As you do more questions, you will remember certain stuff. Because C1 you can't use the calculator anyway. Right, that's the operation 1 is done now. Now let's do the operation 2, second operation. That we have 2 there. The question 2, basically squaring it. We're going to square the whole thing. Okay? Now we're going to square it. Again we do the same thing, exact same thing. We have power 1 here. Can rewrite this one like that. 3 squared x minus half times 2 minus 1. Divide by 2 times 1 is 2, 4 squared. So what you're going to get here, basically 9 x to the minus 1 over 16. Alright. So that's basically second operation is done. The last operation is the index. So last operation, the index minus 1, the power, raising to the minus 1 power. Again, exactly the same thing. Minus 1 times 1, so let me rewrite this here. 9x minus 1 over 16 to the minus 1. Okay? Again, we got 1 there, so we're going to have 9 to the minus 1, x, because minus 1 times minus 1 is positive 1, so x basically. We got here 16, the 1 power 1, 16 to the minus 1. Now again, the powers are negative, so they don't look good, isn't it? So we can swap these things to get the positive values. So I'm going to raise this one, we're going to bring it to the top, and I'm going to bring this guy down. Okay, so what I'm going to get here, 16x over 9. That's the answer basically. Okay, bring this guy to the top. So become positive then. Positive power, which is 16. That bring it not to the down. It's become again positive. These questions are slightly bit long-winded questions. I did on purpose. These are not exam questions or nothing. This is just I prepared just myself for you guys to see a bit of a revision. Okay. So let's then go to question number 3. Right, the third question is an integral. Right, so number 3 question that to integrate 3x squared plus 21x plus 24 divided by 5x plus 5 dx. They say integrate this. Right, this was 21 of it. Right, cool. Now, when integrating, so how do you integrate this? How do you do this? Now, normally, sometimes we misunderstand this kind of questions. What we're going to do, we're going to integrate each one like that. It's like some students tend to write this answer like this. Integrate each term. Okay, like that. And also see. It's totally wrong. Can't do like that. It's wrong. I mean, I've seen many times by mistake, obviously, or misunderstanding, we do this operation. We can't do that like that. We can't. The simple reason is we can only at this level, we can integrate expressions separated by only plus or minus. The terms must be separated by plus or minus. Here, this is separated by also division. So we can't really just do like that each one. We can't integrate like that. So we should be able to get this expression somehow look like something like, I don't know, something like maybe look like x plus, I mean the terms must be separated. I'm just saying, 5x plus 1 or something like that, plus or minus. The terms must be separated by plus or minus. What I'm saying, we should simplify this one somehow to get this terms are separated by plus or minus. Like that, each term. These terms can be x squared, x cubed, whatever. This is fine. But they cannot be divided by another expression like that. You can't. I mean, they can't be. We will study that kind of stuff, when you go to year 13, but not here. Okay? So the first plan is to get this one basically simplified into something like that. There can be many terms, obviously. It's fine. Many terms. Okay. So to simplify, like I think in one of these previous clips I was talking about factorization. I think probably we can consider factorization and see whether we can simplify this expression into something can be written in separate terms. Okay. So let's see what we can do. Let's look at the top part of the function expression. The first things are first, whether we can see whether there's a common factor. 3 seems to be a common factor. 3 goes everywhere. So I can take 3 outside. I'm going to get x squared plus 7x plus 7x plus 8. Right? I think this question there's a mistake here. This is supposed to be 9. Okay. Alright, so this should be 27. The original question, if you guys are trying this one, I have to say sorry. I don't think otherwise you can factorize it further. Yeah. Okay, that's fine. So that's just the question. Change it to this. And 5x plus 5. Okay, so the original question has changed just to one number, 27. This should be 27, not 21. Okay. Right, now we can probably factorize the bottom part as well. 9x plus 8 divided by 5 times x plus 1. Still we can't do anything. Basically, it's not in that format. We can possibly factorize this one. It's a quadratic expression. Maybe we can factorize this quadratic expression. To do that, we can, if you want, you can use a shortcut because this is only one. I'm just going to factorize it quickly. If you want to know the proper way of factorizing, obviously you can learn from one of my previous videos. Or there are many other videos, obviously, or wherever you like, you can just learn it. It doesn't really matter. So let's try and factorize this. It'll be x plus 1 and x plus 8. 5 times x plus 1. So we try to work out two numbers that times them together give us 8. And them together give us 9, isn't it? So we know it's 8 and 1, right? So I did this one quickly in here. And now we can see x plus 1 and x plus 1, they're cancelling out. Okay. Now what we're going to get here is something interesting. We have 3x plus 24 times in that 3 times x, 3x times 24 divided by 5. Now this is far conducive for our work. Now it can be done. So 3x over 5 plus 24 over 5. Now we can integrate this without a problem. Now we can clearly see these expressions are single, these are numbers, so that's fine. There's division there, but they are just numbers, they're constants, okay? And it's also in that format. You know? Separated by just only plus or minus, in this case plus. Now let's integrate it. So what you're going to get here, when integrating, I'm going to raise the power by 1, because the power right now is 1. I'm going to raise by 1, 3x squared, and divide by 2. So when you're dividing by 2, you know 2 times 5, basically 10. Isn't it? Basically dividing the whole thing by 2 means 2 times 5. This will be times together. And here on the other hand, it's become, right now the power is 0, x to the power of 0. So it's become 24x plus divided by 5. And plus c, don't forget c. You will lose marks as well. And also it's very important, c, actually. It's far important than a mark. You can lose marks from somewhere else too. Actually that c is very important. Arbitrary constant. It's an arbitrary constant, it's arbitrary. It depends on something called boundary conditions. They are not part of this agenda. Okay? So keep that in your mind. When you get a question like that, you have to first simplify it to get into something, a polynomial, which is can be separated, written in this format, like that. Okay. So let's try the last question then. Question number 4. Right. So last question is on I think quadratic functions or something. Quadratic functions, question number 4. Let's read it. It says given that x squared plus 6x plus c is a complete square. What they're saying is like a square number. It's like 2 squared, 3 squared. I mean, it's like expression you can write as complete square. Find the value of c. So they're saying x squared plus 6x plus c is a complete square. Or it's just a square basically. It can be written as a square. What they're saying this can be written like, let's say, x plus a squared. We don't know the value of a. I'm just saying something like that. So if this is the case, then find the value of c. Now when you look into the complete square or completing the square, all that things goes to the same thing. Completing the square, isn't it? So so let's try to complete the square here by that technique we know and see what we can do from there onwards. So I'm going to complete the square basically. So when you're completing the square, what we're going to do, we're going to basically write the first x squared as x, because the coefficient here is 1, so there's no problem here, nothing to take out. And divide the 6 by 3, square the whole thing. C was there, bring it down as it was, minus, always minus that one square, 3 square. Okay. Now, what they're saying, that is basically exactly equal to that, isn't it? These two things are exactly equal. They are basically congruent, I mean clones basically, identical. So if this one can be written as a complete square, there you go, that's a complete square, then this should be, what you can say about this? This must be equal to 0. Isn't it? That's the only way we can write this one like that. See, that must vanish. So we're gonna make it vanish. There you go. So what is c equals to then? C equals to 3 squared, which is 9. So when c is 9, it's a complete square. It's a pretty simple question. But I'm pretty sure a lot of us sometimes find it difficult to understand what they are talking about, I think. Right. Part B of it. Hence solve the equation. Hence solve that. So we can sub the values. Solving it, I think, pretty simple now. Sorry, 6x plus 9 equals 0. This is complete square, so we can write this one as x plus 3 squared equal to 0. Okay. So we are trying to work out the value of x. So which means x plus 3 equals to, take the square root both sides, 0 basically, plus or minus, so it's just 0. I just put plus or minus just to show theoretically it is still the case. So x equals to minus 3. Basically the answer is x equals negative 3. That's it. Alright. Cool. So that's basically the 4 questions. Okay. So study these things and we do a bit of investigation rather than just memorizing or something. That's the most important thing. Yeah, try to understand what's really going on. Try to understand the basics. It's pretty important. However, these are not very basic questions, but they're somewhat, yeah, exam-like, if not slightly difficult questions. Sometimes some of them maybe. All right, so that's I think enough for the time being. Okay.